Viana, what are you doing?
Solving this problem using the law of cosines.
Using what?
The law of cosines.
You're breaking the law of cosines. Here's a contract. Can you cosine it for me? Alright class, what's 2 plus 2? Yes, Dom? 5.
Oh, she's so stupid. It's such a sin.
Such a cosine. Up next is the band Inco Sync. This is Vince Gagliardi co-signing off.
The law of cosines is used when you are given the measures of two sides and the included angle of a triangle, and you cannot use the law of sines. The cosine function first arose from the need to compute the sine of the complementary angle at 90 degrees. The general law of cosines was not developed until the early part of the 10th century by Muslim mathematicians. The application of the name law of cosines was near the end of the 19th century. There are many proofs that use the law of cosines, such as distance formula, trigonometry, the Pythagorean theorem, the Thoulon's theorem, area comparison, circle geometry, and vectors. In triangle problems dealing with two sides and two angles, we have seen that the law of sines is used to find the missing item. There are many problems, however, that deal with all three sides and only one angle of the triangle. For these problems, we have another method of solution called the law of cosines. We can use the diagram to the left to create three separate equations. The first equation is set equal to a squared, which is trying to solve for the side length of a in the triangle. It corresponds with angle A, which is shown by the capital letter A at the end of the equation, and you fill in the b squared and c squared and the other b and c with the information that's given to you. You can reconfigure this equation to equal b or c.
Today we'll be reviewing SOHCAHTOA for right triangle trig. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And this works for a right triangle trigonometry, but when you don't have a right triangle, you can use law of cosines. The law of cosines is a generalized Pythagorean theorem, and these equations are used for when you're given two sides and an angle. So say you're solving for side A, and you're given obviously sides B and C and angle A. You use this equation, and then it gives you side A. Same thing occurs if you're looking for side B or side C. So say you're given angle A, you're automatically going to be looking for side A because it corresponds with each other. So the law of cosines will work for all different triangles. Obviously it's going to work for a right triangle, but if you don't have a right triangle, it's also going to work for an acute and obtuse. Say you're solving for angle A, what you're going to do is put the angle that you're solving for at the origin, and the side C is always going to be on the x-axis. In each of these three cases, C is a point on the terminal side of angle A in standard position at distance b from the origin. Denote the coordinates of C by xy. By our definitions for trigonometric functions of any angle, we can conclude that x over b equals cosine A and y over b equals sine A, and therefore x equals b cosine A and y equals b sine A. So to find the length of side A, you're going to use the distance formula between the angles B and C. So that's represented there. Then you're going to square both sides to get rid of the square root. And then basically you're just going to simplify the equation until you get b squared plus c squared minus 2bc cosine A. This is an example for solving a triangle with the law of cosines with side angle side. You're given side A and B and angle C, so therefore you will be solving for side C. Once you solve for side C, you're going to use all three sides and solve for each of the angles separately. Use the law of cosines equation to solve for side C. So you're going to set side C squared equal to the entire equation. Once you get side C, you're going to reconfigure the equation and set it equal to side A, and then angle A and angle B. Once you solve it all, those are all 6 parts of the triangle and all the answers. To solve a triangle with all 3 sides given, or a side-side-side triangle, use the law of cosines to set the equation with all of the sides in it, and then you're going to find each of the angles separately. So you're going to solve for angle A, angle B, and then you're just going to subtract angle A and B from 180 to get angle C.
So this is a side-side-side triangle. So this side is 25, which is A. This side is 37, which is C. And this side is 32, which is B. So now this is the equation we're going to use to solve for angle A. The equation to solve for A is A squared equals B squared plus C squared minus 2BC times cosine angle A. And then we're going to plug in the corresponding measurements, which is 25 squared equals 32 squared plus 37 squared minus 2 times 32 times 7 times cosine A. So once you plug all the corresponding numbers in, it's 25 squared comes out to 625, 32 squared is 2,393, 37 squared is 2,368 times cosine A. Then you're going to isolate cosine A and then simplify to get 0.75 equals cosine A. Angle A equals the inverse cosine of 0.75, which is 41.7 degrees. This is a side angle side problem, and we're going to use this angle to solve for the corresponding side. Side A is 14, B is what we're solving for, and side C is 10.
Alright, we now take this equation and plug in the corresponding numbers for it. For example, A we plug in 14, C we plug in 10, and so on. Then we simplify the equation and we get B squared equals 94.5, and then we take the square root of 94.5 and you get B squared, or just B, equals 9.73.
Now we'll be solving this problem step by step. The problem is calculate the measurement of angle C given the 3 sides. A equals 20, B equals 12, and C equals 14. So we know we're solving for angle C, so we're going to have to set the equation to C squared. This is the equation we'll be using. Now what we have to do is plug all the side measurements into their places, and we'll be left with C with no measurement in it. Next, all you have to do is simplify all of the numbers that are squared, and you're going to continue using the order of operations. So 14 squared is 196. 20 squared is 400, 12 squared is 144, and 2 times 20 times 12 is 480. Next, we're just going to add 400 and 144, which is 544. Next, you subtract 544 from 196 and divide it by negative 480, which gets you 0.725. Now to isolate C, you take the inverse cosine of 0.725. Then when you take the inverse of 0.725, it gets you 43.5 degrees. for this next problem, it is to calculate the length of side A given the two sides and one angle. Side B is 21, side C is 32, and angle A is 40 degrees. So because we are looking for side A, we're going to have to set the equation equal to A squared. Next, plug in the measurements to their corresponding variable. So you put b squared in place of 21 squared, 32 squared in place of c squared, and replace 2bc for 2 times 21 times 32, and replace cosine angle A with cosine 40. Next, all you have to do is simplify the squared and the multiplication and continue to simplify the problem. So 21 squared equals 441 plus 32 squared, which equals 1024. Then you subtract 2 times 21 times 32, which equals 1344. And then you're going to multiply that by cosine of 40, and when you plug it into the calculator, you have to use the degree sign. Set that equal to a squared again. Solve this all out, which gets you 435.436. And since that's equal to a squared, you have to take the square root of that, which gets you to 20.86.
So basically, the law of cosines is simply an equation that can be used whenever you don't have a right triangle or you can't use the law of sines. The law of cosine only works on side angle side or side 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 triangles, and to use it, you plug the information given into its corresponding variable. We made a 15-minute video on one equation. I hope you enjoyed.